Hey everyone, this is the presentation style from the video I've made before, so it's more simpler than before. Okay, so this problem is a holiday package prediction that it is the problem. So from last year's data, we have like efficient marketing, right? A marketing that we define here is when a company invited a customer to take the product, and because last year we used random picking, there's only 21.85% of the customer that we pitch that actually take the product. Okay, and then what about the self-inquiry one? Aren't they not important? No, there are also customer, and actually some of them actually use the product in the end. And yeah, maybe we can try to find another potential customer from this self-inquiry if we pitch them. Okay, so here is the solution that I proposed. So it's a machine learning to predict if a consumer will take the product pitch if we do a marketing pitch to them. So it's based on a Bayesian probability. So it's actually a probability of a consumer will take the product after we pitch to them, like that. Here is the series specification. For the full code you can actually visit my Kaggle here, kaggle.com/alrafikri. And for the dataset, you can click here, holiday package dataset. And the model that we use here is XGBoost. So I've actually experimented with logistic regression, and they have too much false positive, and then I switched to the three best model, start from the Forest, and they have a really nice baseline result. So that's why in the final model I use XGBoost. And for the sample, I actually oversampled the training set because the target variable, the customer that actually take the product, is smaller in value and in count than the customer that didn't take the product. You can see from this graph right here, right? Like there is only around 20% of the customer. Okay, and then I also tuned the probability threshold for the XGBoost to 40%, because we want to maximize the recall and we want to decrease the false negative, right? We don't want to waste any opportunity we have. And for the features, I use 550 features that's selected with chi-square and f-score for the numeric and categorical, and we have 1400 independent rows, so it's actually a pretty small data set, and I think it will be better if we have many more data set than this, because it's only one feature for 75 independent effects, and I'm not satisfied with it. I think it will be I'm satisfied if it's at least 100, but my baseline is 1 in 50, so 1 in 75 is okay. Okay, is the performance from our model. So here is the current marketing performance, right? Like we have so many false positive. We have so many customer that we pitch that didn't actually take the product in the end. And how about the marketing performance? So we have a NAROC of 0.87, and that's quite high. That's nice. And then from the conversion metrics, we have uh, a quite nice composition too. Like the true positive is already higher than the true negative, or the false negative and the false positive. And we actually successfully predicted many ineffective marketing, and the predict prediction for the true positive is not bad. It's 50 per 30 false, if 50 per 13 false positive and 50 per 12 false negative. So I like to think it like this. If we use this model, we the if inefficiency actually decreased from 20, the 222 customer to only 13 customer, but we also sacrifice a little bit of potential customer like 12 customer. But from the cost and the benefit, I think we can uh, what is it, afford it. Okay, it's worth it. And actually, from the classification report, we know that the prediction for the ineffective marketing is really nice, it's high. So we can actually slash 94% of the ineffective marketing costs, and the model can actually predict up to 81% of the available potential customer to be reached, and the precision of near point A actually means that every 5 potential customer there is 1 per 5 risk that the customer is actually not that potential. Okay, so like I said before, we can afford to take the risk because from the data last year, we try to predict. Uh, we try to predict from the customer that is not pitched by us, that is self inquiry, and in the end, the customer didn't take the product. We want to predict like how many customer actually that uh, didn't get pitched by us and they didn't take the product in the end. How many customer there is like that, and is predicted that they will actually take the product if they are pitched by us. Okay, so in this graph we have 530 people that is predicted by our model that will actually take the product if they are just pitched by us. So it's not only a decrease in marketing costs, it's also a potential to increase our revenue based on the customer that we don't pitch before. And they're actually the potential customer, right? And maybe that's it from me, the simpler explanation from the code. And you can actually visit